Let's take a look at a couple more examples of mutually exclusive or not mutually exclusive events. At a political rally, there are 30 Republicans, 50 Democrats, and 5 independents. If a person is selected at random, find the probability that he or she is a Democrat or independent. So the question first to ask is, are these events mutually exclusive? Is being a Democrat and being an independent mutually exclusive events? And they are. You're only allowed to register for one party when you go to vote. So they are mutually exclusive. You can't be both. So then we can create the probability, Democrat or independent. So to find probability of Democrat or independent, since they are mutually exclusive, we can just find the probability of a Democrat plus the probability of independent, and we get our answer. So 30 plus 50 plus 5, we have a total of 85 in attendance. Democrats, there are 50 out of 85. Independents are 5 out of 85. So we have 55 out of 85 total probability. But we don't like those numbers, so we're going to change them. 55 divided by 85, let's get a decimal number. 0.647 or 64.7%. That's one way to do it. Another way to do it, Democrat or independent, that's the complement to the Republicans. We can take a look at the Democrat or independent as 1 minus the probability of Republican. So we could say 1 minus 30 out of 85. 85 out of 85 minus 30 out of 85. Notice we get the same answer as above. So we can approach these problems in multiple ways. So looking at number 2, I did modify it slightly from what you have on your paper. I apologize for that. In a hospital, there are 8 nurses and 6 physicians. 7 nurses and 2 physicians have dark hair. If a staff person is selected, find the probability they are a nurse or do not have dark hair. So the first question we should ask, do we have mutually exclusive events with a nurse and not dark hair? No, because only 7 out of the 8 total have dark hair, so there is 1 nurse without dark hair. And that could mean many things. No hair at all, lighter colored hair, what have you. So, since it's not mutually exclusive, we have 14 total professionals. 7 plus 2, 9 have dark hair. If I want to calculate the probability that I select a nurse or someone with dark hair at random, not dark hair, then I can look at the probability of getting a nurse, the probability of getting not dark hair, minus the probability of not dark hair nurses. How many are both? And so we look at the probability of nurses. There are 8 total nurses out of 14 professionals. Not dark hair. If there are 5 with dark hair, 5 do not have dark hair. So 5 out of 14. But we're double counting the 1 nurse. The 1 nurse that has dark hair, we're counting that person in the nurses and in the dark hair, so we have to subtract them out. And that'll get us 12 out of 14, which is 6/7 or 0.857 in our calculator. And this is just giving us that opportunity to use that formula. We could look at this though and say, I have 9 with dark hair, so 5 don't have dark hair. Since 5 don't have dark hair and 1 of those nurses has dark hair, then I need 7 more. 5 plus 7 is 12, and we can get the same answer using intuition. So we can count these in different ways, and that's okay. In our last example, we're going to do this same problem 2 different ways. And we're going to look at the outgoing Congressional Senate and their makeup. The 116th Congressional Senate, which ran from 2019 to 2021, is made up of 45 Democrats, 53 Republicans, and 2 independents. 8 Republicans and 17 Democrats are women. If we randomly select one senator, what is the probability of getting a man or a Democrat? So let's break this down. We have, in the Senate, we have a total of 100 senators, 2 from each state. Notice we can add these together. 45 Democrats plus 53 Republicans plus 2 independents. 8 Republicans and 17 Democrats are women. So this group right here, 8 plus 17, are 25 women. That means the rest of them, 75, are men. That also means if I just look at the Democrats, focusing in on the Democrats, since I'm asking a man or a Democrat, I want to know how many Democrats are men. So 45 total Democrats, 17 are women. So 45 minus 17 will give me 28 men Democrats. I can see that because of this is not mutually exclusive. So let's see how we can apply the formula. So probability of getting a man or a Democrat. Probability of a man, we had 75 of them. Probability of a Democrat, we had 45 Democrats in that last Senate. And the men Democrats, right up here, 28. And if we pull out our calculator, not really a good place for it on my screen, but we'll make it work. 75 plus 45, notice that's bigger than 100. We have overlap, we need to take them out. 92 out of 100, or if we're writing it as a decimal, 0.92, or as a percent, 92%. That's one way to approach the problem, the formula. But we can also do it intuitively by setting up a table. So let's look how to set up the table. So let's organize our information. 45 Democrats. This is the exact same problem we did before. 45 Democrats, 53 Republicans, 2 independents, for a total of 100. 8 Republicans and 17 Democrats are women. So that leaves no independents. Both of the independents are men. So notice how I was able to calculate that. If none of them are women, the rest of them must be men in this situation of our 116th Congressional Senate. So 45 minus 17, 28 Democratic men, 53 minus 8 will give us 45 Republican men, and then we can add across to get our totals. We have 75 men, 25 women. So we're basically breaking apart all 100 into these 6 different categories right here in the middle, okay? And now if we want to count a male or a Democrat, if we want to find a man or a Democrat, we would look at the Democrat column and we would look at the men column, the men row. We could take the men, 75, and add to it, not 45 this time because we've already counted the men Democrats in this group of 75. So we only need to add 17 for the women Democrats. And notice when we do that, 75 plus 17 will also give us 92 out of 100, which is exactly the same answer we did before. Okay, great job. Mutually exclusive events are events that cannot occur at the same time. So we have to be mindful when we're calculating probabilities, whether we have mutually exclusive events or not. If we do, we can just add up the 2 different sets probabilities. But if we don't have mutually exclusive events, we have to make sure that we don't double count the simple events that they have in common. If we do double count them, we want to make sure that we subtract out that double counting so that we're only counting them once.